Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young. Chapter 1, Theorems of Alignment and the Principle of Duality. Section 8, the first assumption of extension. The theorems of the preceding sections were stated and proved on the assumption, explicitly stated in each case, that the necessary points and lines exist. The assumptions of extension, E, ensuring the existence of all the points, which we consider will be given presently. The first of these, however, it is desirable to introduce at this point. An assumption of extension, E0. There are at least 3 points on every line. This assumption is needed in the proof of the following. Theorem 5. Any 2 lines on the same plane pi are on a common point, by assumptions A and assumption E0. Proof. Let the plane pi be determined by the point P and the line L, and let A and B be 2 distinct lines of pi. 1. Suppose A coincides with L, figure 6, if B contains P, any point B of B, by assumption E0, is collinear with P and some point of L equal to A, which proves the theorem when B contains P. If B does not contain P, there exist on B 2 points A and B, not on L, assumption E0. And since they are points of pi, they are collinear with P and the 2 points A' and B' of L respectively. The line joining A on A'P to B on PB' has a point R in common with A'B' by assumption A3, i.e. L is equal to A and B have a point in common. Hence, every line in the plane pi has a point in common with L. 2. Let A and B both be distinct from L. Let A contain P, figure 7, the line joining P to any point B of B, assumption E0, has a point B' in common with L, case 1 of this proof. Also, the lines A and B have points A' and R, respectively, in common with L, case 1. Now the line A'P equal to A contains the points A' of RB' and P of B'B, and hence has a point A in common with BR equal to B. Hence every line of pi has a point in common with any line of pi through P. Let neither A nor B contain P, figure 8, as before A and B meet L in 2 points Q and R respectively. Let B' be a point of L distinct from Q and R, by assumption E0. The line PB' then meets A and B in 2 points A and B respectively, by case 2 part 1. If A is equal to B, the theorem is proved. If A is not equal to B, the line B has the point R in common with QB' and the point B in common with B'A, and hence has a point in common with AQ equal to A by assumption A3. Theorem 6. The plane alpha determined by a line L and a point P is identical with the plane beta determined by a line M and a point Q, provided M and Q are on alpha, by assumptions A and assumption E0. Proof. Any point B of beta is collinear with Q and a point A of M, figure 9. A and Q are both points of alpha, and hence every point of the line AQ is a point of alpha, by theorem 4. Hence every point of beta is a point of alpha. Conversely, let B be any point of alpha. The line BQ meets M in a point, by theorem 5. Hence, every point of alpha is a point of beta. Corollary. There is one and only one plane determined by 3 non-collinear points, or by a line and a point not on the line, or by 2 intersecting lines, by assumptions A and E0. The data of the corollary are all equivalent by virtue of assumption E0. We will denote by ABC the plane determined by the points A, B, and C, and by AA the plane determined by the line A and the point A, etc. Theorem 7. two distinct planes which are on two common points A and B, A not equal to B, are on all the points of the line AB and on no other common point, by assumptions A and assumption E0. Proof: by Theorem 4, the line AB lies in each of the two planes, which proves the first part of the proposition. Suppose C, not on AB, were a common point to the two planes. Then the plane determined by A, B, and C would be identical with each of the given planes by Theorem 6, which contradicts the hypothesis that the planes are distinct. Corollary: two distinct planes cannot be on more than one common line, by assumptions A and E0. Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renhold, with programming and illustration by Jim Renhold, 2019. Thank you for listening.